as our first renewable energy. Okay, solar energy we can consider, according to this syllabus, we consider that solar energy is our first renewable energy. Now, as far as we're concerned, that when we talk about energy, there will be two kinds of energy, what we call as non-renewable energy, whereby non-renewable energy is mainly come from the oil and gas, oil and gas, and then we have the nuclear power, and etc. We got 4 types of non-renewable. But there are, on the other hand, there are varieties type of, there are varieties type of what we call as non-renewable energy. Okay, non-renewable energy. Okay, right. Where were we? Okay. So, where were we now? Okay. Now there are varieties type of non-renewable. That's why, sorry to interrupt everybody now, because that's why I don't like to some of you. Okay, you are late now. One of you are late. So the time is about 2:18 now. 3 minutes after 3:15. 2:15. So I'm supposed to proceed my lecture, but now it's interrupt my lecture now. See, because of one student. All right. Okay, that's why. So please be in my class, be online in my class at least a quarter past 2, before 2:15. Okay. We have renewable energy. Okay, right. So we today we proceed on this topic. Okay, under this topic we cover about the radiant energy. We talk about the law of blackbody radiation, and then we look at on the some concept of the atmospheric gases, because this is related to the solar energy as well. And the last one is solar energy and its use. Okay, right. Now, over here I have the note. Okay. Right. So we talk about this. Okay. Right. Solar energy and its interaction. Right. This topic will cover the following, as I mentioned just now. This following topic: radiant energy, solar energy distribution, interaction with the atmospheric gases, up to the greenhouse effect. And then last one, we talk about the solar thermal energy and its use. So what is the solar energy, by the way? What is solar energy? All right. If we look at from this slide, okay, solar energy is considered as I mentioned, we have a varieties of non-renewable energy. As I said, non-renewable energy is cover the following energy, which is mainly come from the coal, charcoal, and then from the uranium. Uranium is the main source for nuclear power, and this uranium will be depleted from time to time. Okay, from time to time, this uranium will be depleted and could be gone. If many people use nuclear power, then could be uranium will be depleted. Okay, no more resources of uranium. Okay, I think in the test 1 I asked you about this. Okay, the answer is if uranium depleted, then the uranium is depleted. Okay, then we have the oil and also gases. Right, all these are considered as under non-renewable. But however, when we talk about renewable energy, okay, the main energy, the main See now, because of one, I will not allow this guy or this lady in my class. Because really annoying. I start my lecture already, now interrupt my lecture now. See? That's why I ask everybody to be in my lecture at 2:15. So I consider for those who are not attend, okay, one attend at after 2:15, I consider they are absent my class. Okay, really, it's really annoying. And then I record now. Yeah, I record lecture. Now where is interrupt? Yeah, my recording. All right. Now, where were we just now? Okay, before we start, we need to look at on one video. Yeah, I have one video, so please watch this video. Yeah, right.
You might have seen videos like this before, but here's the big secret. Anyone can make one of these videos in a few.
Okay. Now we have this. Now, okay, this is the farm of solar panel. Yeah, right. You can see a lot of solar panel here. Okay. And even you see there is no such forest, no such tree. Yeah. Normally all these solar panel will be installed at the open area, such as like a desert. Yeah. Okay, so on. Okay, we have another one video. This one, okay.
Solar energy. Did you know that all of the energy we use comes from the sun? You probably know that's true for solar panels, but the sun is also the ultimate source for energy generated by wind, water, and fossil fuels. It works like this. Heat from the sun drives the air currents and water currents that turn wind turbines and power hydroelectric dams. Meanwhile, the rays of the sun also help the plants grow that ultimately become wood, coal, and gas. What if we could cut out the middleman to open the most direct path between the sun and the energy we use every day? Let's take a step back so we can understand the real power and potential of the sun. The sun is a massive, flaming sphere of gases, 330,000 times more massive than the Earth. At its core, the sun is 27 million degrees Fahrenheit.
Okay, this is the temperature of the sun, and even the energy just now, you can see the number, yeah? Very huge number.
Which is 60,000 times the temperature of your oven.
You see, approximately about the temperature on the surface of the sun is approximately about 60K time compared to the surface of Earth's temperature, yeah?
When you bake a pizza, the sun gives off lots of energy into space as heat and light, called solar energy. If we could capture all of the solar energy that reaches the Earth's surface, we could continuously run a 25-inch television on every square meter of the Earth and still have energy left over. Right now, we aren't using all this energy. Instead, we mostly rely on coal, oil, natural gas, and other resources. But these sources aren't renewable, which means they'll eventually run out. In fact, if we keep using these non-renewable resources at the rate we are now, we may run out of oil and gas in the next 50 or so years, and coal in the next 115 years. Not only
Now, see, this is the period, yeah, that they predict, yeah. Okay, right. We are now somewhere around 2021. So what happened another next 115 years, or maybe 15 will we will run out the coal, or maybe we run out these natural gases and also the oil, yeah. Okay. So therefore the alternative will be the solar energy, or we call another one is we call any kind of renewable energy, yeah.
are these non-renewable resources going to run out, they're also polluting our planet and contributing to climate change. The sun's energy, on the other hand, will not run out for the next 5 billion years. That makes it a renewable resource. Other renewable resources, like wind and water, can also provide us with energy. But even all the energy we can get from all these sources added together is still less than 1% of the solar energy reaching the Earth. It's clear that the potential of solar energy massively outshines its competitors. How exactly do we harness solar energy? Solar panels directly convert sunlight into usable electricity using special materials like silicon. Another way to harness solar energy is through a process called concentrated solar power, which uses thousands of mirrors to reflect sunlight onto a tower. The heat captured in the tower makes steam that flows through a steam turbine, which generates electricity. But even though we have these promising technologies to capture solar energy, there are still many challenges with using solar energy on a large scale. For example, the amount of solar energy we can harness can change based on place and time. Some parts of the world get much more sun than others. Solar panels in the Sahara Desert will produce more energy than those in Seattle. But even in the sunniest places, the sunlight still isn't constant. The changing of seasons, the cycle from day to night, and even clouds in the sky can reduce the amount of available energy. To make solar energy usable, when and where it's less available, we need to improve energy storage and transmission systems. Above all, we also need to make solar technologies more efficient and less expensive. Currently, less than 1% of all energy produced and used in the United States comes from solar energy. But as more researchers, private citizens, entrepreneurs, and government agencies are recognizing its amazing potential.
Okay, this is in the case in America, yeah. All right. Anyway, okay, we look on the note now. Okay. Right now, what we can see now, when we talk about the power of the solar, it's about 23K. Yeah, in the slide just now you say about 33K. Terawatt, this is terawatt. Yeah, terawatt. And compared to others, this is solar, this is tidal or wave, which is about approximately about, we can have a look over here. Tidal and wave is about probably about 0.3 terawatt. Geothermal 0.3 as well. Similar to both tidal and wave. Hydro 3 to 4. Biomass 2 to 6. Wind. Okay, wind is quite bigger bit, which is about 25 to 70 terawatt. And we can see from all this category of solar energy, we can see that, all this renewable energy, we can see that solar energy is much, much bigger yeah, value compared to all this. That's why solar panel have become the most dominant, the most important energy sources for renewable energy. However, you have to notice that we cannot collect all the energy from the solar. We can use only certain amount only. It's like a sugar as well. Sometimes we need sugar. Yeah, we need a sugar. If we want to make a coffee or tea, you need to add with a sugar. You need to add appropriate amount of sugar in your cup. If you put more sugar at the end of the day, what happened to you? When you're getting old later on, for another at around more than 40 years, then you will be end up with a diabetes. More sugar is dangerous. It's quite similar. This is the analogy for the solar panel. We cannot use the whole power of the solar panel, solar energy. Why? Because we can only use a certain amount only. Certain amount of energy only we can use. Okay. What is solar panel? What is solar energy? Solar energy is radiant light. When you say radiant, it's cover 360 degree. We cover the entire area of the earth. But because of the earth, you can see it's only cover because the earth is rotating, therefore the solar, this sunlight or radiant light from the sun, okay, will be irradiate about half of the earth's surface, as because we know that the earth is rotating. So mean that the solar can be only used at the daytime, not for the night time. So we need a battery then, a battery to back up the power. So that's why in our previous topic, we talked about energy storage. In our previous topic, in the chapter 3, I think I have delivered to all of you about the energy storage. So in the energy storage, we have a battery concept, the concept of battery. So in this context, solar energy also have some limitation. It has limitation, by the way. Okay, so solar energy need energy storage, and solar energy as well need energy, what you call energy accumulator. Energy accumulator. What is energy accumulator? It's a solar panel. Okay. Now, when we talk about this energy, it's not only light, but it's also covered with the heat. You can see, the temperature of the surface of the earth, of the sun just now. Yeah. The heat is very, very. The massive amount of measurement of temperature than compared to Earth's surface. Right. The technology that cover from this solar energy is solar heating, solar photovoltaic, or what you call as solar panel. Okay, I will explain this in the chapter 5. Okay, afterward. Okay, maybe somewhere around next week. Yeah, solar thermal, electricity, solar architecture cover also. Solar architecture mainly more to orientation, because as I said just now, in order to accumulate the solar, we need to put the solar panel at the open space. That's why we need to consider where is the location. We need to install our solar panel. This with respect to the solar architecture and artificial photosynthesis. Okay, as we know, all the plant, the leaf from the plant have a photosynthesis. Okay, all the plant grow because of there is a photosynthesis. And in photosynthesis, okay, we produce the oxygen. So the leaf have a pigment, right? Photosynthesis is come from the pigment of the leaf. That's why all the leaf with a color of green color. Why a green color? Why green color? Why God create? Why Allah create? Yeah. Allah create the color of the leaf is in the green color. This is one of the interesting fact that we need to think, because green color is considered as black body radiation as well. Because it's easy to, with this kind of color, we allow the leaf to absorb the solar energy easily. Yeah. All right. Okay. I will explain to you about the black body radiation later on. Yeah. Okay. Right. Now, solar energy, solar technology are very broad, very wide, characteristic, either passive. So this is covered under what we call as solar architecture. Yeah. Right. In order to install the solar technology, we need to have a two category. Yeah, we need to consider two category of solar, which is number one is known as this one, yeah, passive solar, and second one you call as active solar. Active solar. Okay. Now it depends on the way they capture the way. So that's why we need to change the orientation. Okay. Depend on the way they capture, depend on the way they convert, the distribute energy. What is active solar technique? Okay, active solar technique include the use of photovoltaic panel and solar thermal collect. So in this context, we have a device such as photovoltaic panel and solar thermal collector. This is to collect the what? The light. Okay, this one is to collect the heat. The heat. Yeah. All right. For passive technique is include the orientation. The word orientation of the building. Mean that if you construct your house somewhere around nearly the forest area, it's covered by a lot of tree, it's impossible. It's not possible for you to collect the sun light directly, easily, yeah, compared to if you construct your house somewhere around the open area. Yeah, maybe on the top of the mountain, maybe around at the desert area, yeah, at the open space area, very easy for you to collect this energy. Okay, and we talk about there are many factors then, many factors. So we have to notice there are two types of way we can collect this energy, which is number one, active solar. Okay, active solar, more to the use of device such as photovoltaic and solar thermal collector. Passive is mainly depend on the orientation of the building. I mean the position. Yeah. Right now, if you look at on the way how the solar energy or the light come to the surface of the earth, we know that between the earth and the sun, there are many planets. How many planets we have until now? Yeah, how many planets? You count how many planets? We have the Mars, we have Mercury, we have Neptune, we have Jupiter, and so on. Okay, in between the gap between the sun and the earth, there will be a vacuum. We know that at the outer space there is mainly a vacuum condition. Okay, no such living thing can exist except UFO. Yeah, UFO or alien. Okay, might be, yeah. Okay, then because of there is a vacuum between the sun and the earth, so it means that the light from the sun can be easily propagate and reach to the surface of the earth without any loss, without any energy loss. That's why there is a vacuum. And we need to notice that when we talk about the light from the sun is mainly what we call as electromagnetic wave. Yeah. The sun ray is considered as electromagnetic wave. When we talk about electromagnetic wave, yeah. But what you know with the electromagnetic wave? Okay. When we talk about electromagnetic wave, okay, it's like this one. Okay, electro. The word electro is come from this one. Yeah, the electric field. Magnetic stand for the B. So in this case, you can see the wave, the component of electric field. Yeah, in the electromagnetic wave is, you can see in the red or the pink color here. It's like a sinusoidal shape. Okay, in this axis, because this one could be parallel to y-axis. While for the magnetic wave, the magnetic sinusoidal wave is perpendicular, which is 90 degrees, respect to the electromagnetic wave. This angle is 90 degrees. Yeah, between the pink color and the turquoise color is 90 degrees. So this turquoise color is the magnetic field. So this we call as a electromagnetic wave, and this is the wave from the light. Okay, while it is moving, the motion of this light is in x-axis. Okay, in x-axis, which is what? Which is parallel to both B and E propagation. Okay, yeah. When you look at this picture, you can see. This is the speed of light. Okay, so this is the electromagnetic field. So this is the magnetic field. So both of the component will be propagate. I use the word of propagation. Propagation is the motion of the wave. When the wave is moved, we call as propagation. Yeah. So this wave will propagate with the speed of light, which is c, in this direction. Okay, this is the solar. Right. Now you imagine if there is a component of electric and magnetic field. It's supposed to have the what? Energy. There is a packet of energy from here. Yeah, the packet of energy from here. Okay, right. Okay, now we look on this. Right, now I mentioned to you about the electromagnetic field just now, right? Now the concept. Now we know that how the electromagnetic field look like. All right, now the electromagnetic wave from the sun, what we call we call as the light, yeah, the light, irradiate, yeah, on the surface of the earth. This is the way how, yeah, the light, and we know that this is a vacuum, but unfortunately, sometimes there is the atmosphere. We know that our earth are covered with various type of atmosphere. Okay, atmosphere. So what we can see sometimes maybe we call as the lowest one that we can see could be related with the cloud. The cloud as well. The cloud. For example, if you are in the open area of the desert area, You might be noticing that it's very, very hot over there because there is no shelter. No shelter. But one after the cloud moving and on the top of your head. So you will be feel we will have get the shelter. Yeah, there is no light. The light will be absorbed by the cloud. Am I right? It's not absorbed by the way because the cloud will be reflected. You see? So one after the incoming solar ray with this power 100, for example, 174 pentawatt, already on the surface. Now, it doesn't mean that the entire amount of energy here will be reached to the surface of the earth. No, it's not. It's not. Okay, why? Why? You can see some are reflected. If there is no atmosphere, now in this case, atmosphere we consider act as a filter. It's act as a filter. If all creature, maybe if all the entire solar energy reach to the surface of the earth, I believe it could be some disaster to all creature on the surface of the earth. Maybe, yeah, the river will be drought. There is no water in the river. All the water in the river will be gone because it's too hot. Maybe the sea level will be reduced. Even all the people, all the creature will be dehydrated. No water. And the surface of the earth become very hot then. Now you imagine if there is no cloud, there is no atmosphere. It look like we receive the whole amount of energy. The energy is very, very high then. I mean in terms of the thermal energy. Yeah. So that's why we on the our earth are surrounding with the atmosphere, and sometimes we know what they call as the effect from the greenhouse, which is damage the ozone. We have an ozone area whereby ozone is acting as a filter, filter of ultraviolet light. If there is no such filter, the ultraviolet light will be reached to the surface of the earth, and then we will what? Receive this ultraviolet light, and this ultraviolet light can induce what? Some disease to our skin. It will damage our skin. Yeah. And even our eyes. Yeah. It will damage our eyes as well. That's why when there is the eclipse, the sun eclipse, especially sun eclipse, you cannot look at directly. Yeah. As we know, I mean, you cannot see directly because it's too bright. Too bright. It could be damage your eyes. Yeah. That's why in some case, if you go to the beach area, you give the open area, you need to wear the special sunglass. Yeah, you need to wear a special glass like a Ray-Ban, the black coating one, in order to reduce the amount of the light that maybe go to your eyes then. So this solar will be reflected. Some solar will be reflected by the atmosphere. Some will be reflected by the sun. And even some will be reflected by the surface of the sun. Mean that some amount of this incoming solar will be absorbed by all this event. And one after the sun, the ray of the sun reach to the surface of the earth, it will be absorbed. And we need to notice as well that our earth, our earth have the capability in reflecting it will reflect some amount of energy from the sun. So in this case, you can see if 174 pentawatt, okay, incident of solar come directly to the surface of the sun, the surface of the earth, 101 pentawatt will be reflected. Or it's not only 111 or plus this one as well. See, mean that it doesn't mean that 174, the whole entire energy of 174 pentawatt can reach to the surface of Earth. No. Yeah. And some other we absorb. So therefore, from here, only 86% pentawatt we absorb by the land or the sea. Yeah. And even this is it, we talk about the power. If we talk about temperature, that's why. That's why in our country, our temperature is around 30 something. 30 something, maybe we can reach to the 40 sometime. You imagine if 174 reach to the surface of the earth, what happened? The temperature of the surface of our earth will be what? Become more than 60 degrees. We cannot survive. Yeah? You imagine. That's why. Atmosphere is one of special thing that created by God. Okay? Right. Now you see, very annoying now. You cannot go into this. You cannot log into my class, but then send me the WhatsApp to me. Very annoying. So my warning to all of you, please, 2:15, all of you must be online. If you don't understand this, I don't know what to say. Now, again, this spoil my recording. Okay? Right. Don't ever, I told everybody before, I told everybody to be in my class at 2:15. Then this guy, this lady, she or he didn't understand. She cannot go into on my online class and then she sent me a WhatsApp. Spoil me. Don't ever do that. A warning to everybody of you. Right. About half. Now you see, if this one is 89 pentawatt, this is 174. It's about nearly half have been what? Only half of the energy will be what? Reach to the surface of the earth. Okay? Right. Now, as I said just now from this diagram, we can see that half of the energy from the sun only can reach to the surface of the earth. Why? Because of all these events. Some are reflected by atmosphere, some are reflected by the cloud, some are reflected by the surface of the earth. Right. Now, you can read all this, and even we have some other event like the convection. Yeah, convection. And we talk about when we talk about the electromagnetic wave just now. Electromagnetic wave, like I said just now, is mainly cover. This is the main one. This is how the electromagnetic wave look like. But electromagnetic wave is actually include or cover the whole type of wave, from radio wave up to the gamma ray, from the long wavelength to very short wavelength, which is gamma ray. All this we call as what we call as electromagnetic wave. Yeah, right. Right. Now, the spectrum of the solar, therefore, the spectrum of the solar light at the Earth's surface is mostly spread out across the visible. Okay, therefore, because of the electromagnetic wave, is mainly contained with varieties type of this kind of wave of radiation. We have the short wavelength. We have a long wavelength. Long wavelength is mainly maybe radio wave, radar wave, microwave, yeah, infrared wave. Okay, all these we cannot see with our naked eyes. Am I right? You cannot see with your naked eyes, and even the size of this wave is very big. You imagine this is about the wavelength of this is about approximately like 1 kilometer. That's why you can receive the signal from the radio. That's why you can receive the radio from you can receive the signal from the television antenna or the astro antenna of the parabolic antenna, because we have this wave. And then radar wave, a microwave that you use in the kitchen, infrared. But then we have this one. This is visible light area. This is the light that allow us to see surround us. We can see surround us because of the existence of this light. Am I right? Yes. If you cannot believe me, you turn off the light. You turn off the light, you stay in the dark room, you didn't see anything. You didn't see anything. That's why we need infrared. Sorry, not infrared. This one, yeah? The visible light. This visible light. All these visible light are contained with this color. Purple color. This one, all the 7 color. Now, this we call as the visible light, the rainbow color light. Yeah, the rainbow color one. All this color. All this color will allow us to see. We can see the people around you, and etc. The plant and all whatever we have on the surface of the earth. Yeah, right. No, mean that our eyes only can receive this light. This light allow us to see everything surround us. And then we have a short wavelength. This is a long wavelength. This is short wavelength. Okay, but we go to here, we cannot see anything. We cannot see the ultraviolet. And then X-ray, you cannot see the X-ray. Gamma ray as well. Even the cosmic ray. Cosmic ray is mainly exists on the what? At the atmosphere. Atmosphere. If you travel using aeroplane or plane, when you go to the higher altitude, then there are many cosmic ray. We must be careful. Many cosmic ray. Or maybe you go to hilly area, like you climb the mountain, for example. There could be some amount of cosmic ray. This cosmic ray is quite dangerous. Cosmic ray is quite dangerous then, because cosmic ray is interact with your skin and will be what? Can induce cancer. Quite similar to gamma ray as well. Yeah, this kind of ray is very, very short wavelength. When you have this is very short, it's very easy for cosmic ray and gamma ray to or X-ray to penetrate into your skin. Yeah, gamma ray. That's why gamma ray can penetrate to your skin because it's very short, about approximately about this scale, 10 to about nanometer scale, and this one is about 10 to the power -12. Right, all right. So I'm not going to talk about the radiation over here, but what I'm trying to say is this is all the type of the wave in the solar. Okay. Right. That's why sometimes we receive more solar with a higher temperature, then it's quite risky to us. That's why our Earths are protected by a layer. This layer. Now, therefore, we have a variety type of the wave, which is visible, near infrared, near ultraviolet. Okay, right. Even there is an event if the Earth's land, surface, ocean, and atmosphere absorb, as I mentioned just now, the solar energy radiation. So sometimes maybe we feel very hot, sometimes we feel very warm, sometimes maybe very cold, but all these are due to the atmospheric circulation. Which called as convection. Right now, we need to notice that the Earth have a capability to reflect, and also the Earth also have capability to absorb the energy. That's why if you walk without using any shoes during daytime, especially at the middle of the day, at the afternoon, if you walk at the area like the area on the road, for example, on the stone, without any shoes, you feel very hot then. Very hot. That's why we need to use a shoes. Why we need to use a shoes? Because shoes is a insulator. Shoes is the insulator. Insulator to prevent your feet from contacting with the hot surface of the earth. That's why we used to use the shoes. Okay? Right. During the time. Right. The total solar energy, okay, you can read all this thing. Okay. Now, if you look at on the comparison here, the solar will give you about this huge amount of energy. The wind is about this, exajoule. EJ stands for exajoule. Exajoule is approximately about 10 to power by 18 joule. Very huge amount of power, which is all equivalent to 278 billion kilowatt. Billion kilowatt. Yeah. All right. Biomass around this one electricity. Mean from here, you can see solar contribute is a long last until the end of the day. Okay. The sun will be there. Okay. The sun will be there until at the end of the earth. Okay. Right. So mean that. But anyway, it depends on the what? Because as I said, as the earth is rotating, sometime we have a daytime, sometimes we have the nighttime. During nighttime, we cannot use the solar energy. Right, this is another clear picture. This is the summary of what is actually happened just now. As I said, the incoming solar panel with 100% of energy go directly to the surface of the earth. From 100%, only 51%, only half is absorbed by the surface of the earth. The rest is reflected by the atmosphere. The rest are reflected by the cloud. And the rest is also reflected by the surface of our earth. And there is some other event over here. So mean that 50% are reflected by the factor of from the cloud, from the atmosphere, and some other reflected by the surface of our earth. That mean that only half or 51% is absorbed on the surface of our earth. So this the one that we have give us what? That's why sometimes our temperature is what? 27, 30, 40. Yeah. What is the highest temperature of the earth in the human history? 40 something, right? Especially at the Sahara Desert. Yeah, but I reckon that it could be the temperature because of the global warming. The temperature of the earth will be higher and higher later on. We don't know what happened in the future. Yeah, that's why don't ever contribute to the destroy of the ozone layer. Yeah, because ozone are very important. Without ozone, yeah, we cannot filter anymore the solar that is. So we know, yeah, the solar have advantages to us. But in some case, we need to consider there are some other things that we need to take special precaution. Yeah, more power of solar reach to the earth will be, you imagine, in other words, you say judgment day. There is no filter if the entire energy of the sun irradiate the earth, then there is nothing to say. Everything will be melting. What happened to the human? We are frying. All of us, all the creature on the earth will be frying, yeah? We cannot survive. Right? Talk about the radiant energy. The radiant energy. When we talk about this radiant energy, we are related with the black body radiation law. As I said, electromagnetic radiation include the following radiation. Visible radiation, we have the radio wave radiation, microwave, X-ray, up to here. All these form of energy are characterized by the oscillation, travel or propagate oscillation, or the combination of electromagnetic field and electric and magnetic field. Okay, right now all these are contain all this. Okay, as I said many times. So all these are make up. All these are we call as from the radio wave to gamma ray we call as electromagnetic wave. Right, when we talk about this, the solar will be absorbed. The solar will be absorbed. Now, in order to absorb, okay, the object need a special color. The object need a special color. That's why if you look at on the color of our Earth, yeah, you can have a look. The planet, we talk about the planet. If you look at on the planet, this one, yeah. Every single planet have a different color. This is our sun. This is the Mercury planet. This is the Venus planet. This is the Earth. Okay. Now, it's quite interesting fact why Earth are very suitable for us. Because of the position of the Earth are fair enough. And even the Earth, even though the Earth are very quite close to, we can consider very quite close to the sun, but we need to notice that surround the Earth here, we have the layer, what we call as atmosphere layer. It's covered by the atmosphere layer. Yeah. And we have the Mars. We have the scientists. The scientists nowadays, they are focused on study or investigate what they are in, what we have in the Mars. But anyway, the surface of the Mars is not similar to the surface of the Earth. Even the color of the Mars as well. You can see the red color, the reddish color. Now, no tree, no creature. It's like a desert. Nothing. No living thing. Except alien. Yeah. And then Jupiter. Quite big. Saturn, Uranus, Neptune, Pluto. And then we don't know the rest. Yeah. Right. Anyway, when we talk about the color, that's why you can see the color of every planet are different. Why different? Because the color is one of the characteristic The color is considered one of the characteristic, the capability of the object to absorb the solar energy. That's why, for example, during daytime, if you're wearing a cloth, yeah, a t-shirt or whatever, what color normally suitable for daytime? What color? Normally, you use what? Could be white color. White color can reflect the heat. If you use black color, or maybe you want to buy a car, for example. It's good one is you call one analogy you want to buy a car. What color? Red color, black color, white color. Which one? Which one we want to go? You buy a black color car, it's quite, well, you know, from your eyes, it will be very nice. But if you didn't turn on the engine and you leave it under direct sunlight, then during the, especially at the middle of the day, and then when after you open the door, you want to drive, then you see inside the car very, very hot because the color is black color. Black color absorb more sunlight. But if you buy a white color, maybe the temperature inside the car is quite reduced. Yeah, because black color, it can reflect. Only white and also gray color. Gray and white is good. Gray and white is good color to reflect the heat from the sun. But if you buy the red color car, the black color one, the dark green color, dark green colors, similar to color of the leaf. You know, the leaf easy to pick up the solar because of its color, its pigment color. Pigment is green for the leaf. Green color, red color, black color. You can be up with, I mean, you see that inside your car very, very hot and later on. Yeah. Okay. That's why even the surface of every planet, we different. Yeah. Neptune. Over here, of course, when you go far away from the sun, the temperature over here very, very, very cold. Maybe minus 100, minus 1,000, minus 1,000. We don't know what is temperature. You can Google what is temperature at the Uranus, Neptune. We cannot survive. That's why on the Earth have very special color. The Earth is contained with a special color. You can see now the Earth, our Earth, contained with mainly the ocean color, blue color. And then on the Earth we have the tree, we have the dark, we have a green color, the Sahara Desert here. And then we have this thing. And also, as I said, the surface of the Earth are covered by this layer, this protective layer. You see, the atmosphere. You see this one? Right. When after the direct sunlight go inside there, and then we be filtered by all this layer. Yeah. Right. This is one special thing that we have on our Earth. Okay. It's created by, of course, by God. Yeah. Right. Right. I hope everybody can understand what I say. Yeah. Okay. Next. Because of that, there is a concept. When I say about color, there's a concept of black body radiation. Why we call black body? Because black color is the common color, that is easy to absorb the thermal energy from the solar. Right. When you saw about this, Okay, green, black color. An object radiate unique spectral radiation flux. Flux mean, as I said, radiant flux, 360 degree flux. Yeah, the intensity. Yeah, radiant flux. If what is radiant flux? You can have a look in the picture. If you understand what is radiant flux, this is the definition. Where is the picture? This one. This we call as radiant flux. If you sun, this is the radiant flux. Yeah, this one, yeah. The circle here. We call it as radiant flux. Right, depend on the temperature, emissivity, the temperature, an object here, okay, and then this radiation called as thermal radiation, of course, solar energy, yeah. Thermal radiation is of course solar radiation from the sun. Okay, and also we need to notice that all these are solar that reach to the surface of the earth mainly come from the varieties of wavelength. And also it will cover with the every single wavelength will be characterized different what temperature as well. Yeah. And thermal radiation can be explained by in terms of the black body theory. In black body theory, yeah, we define as this one as a thermal radiation of the black body. Black body radiation is defined as thermal radiation of black body. That's it. And can give by a Planck law as a function of temperature and wavelength. Okay, black body is the what? Capability of the object to absorb the solar energy. Okay, which is depend on these two, temperature and wavelength. Two categories. According to the Planck law, okay, this is the Planck law. Okay, Planck law state that this one, B lambda equivalent to 2 h c square divided by lambda powered by 5 multiplied by 1 over exponential bracket hc divided by k lambda t minus 1. Whereby, sorry, coincidentally I opened this. I don't know what happened to my slide. Let me close my WhatsApp for a while. Okay. Right, whereby the B lambda is black body spectral radiant. This parameter is we call as black body spectral radiant with the unit of watt per meter per star radian. This is star radian, micrometer. And T is temperature, of course, temperature in Kelvin. Lambda is the wavelength. Lambda will depend on the what? As I said now, this lambda will depend on the electromagnetic wave. Just now. That lambda we may depend on this. The wavelength of this radiation. Yeah, this one, yeah, we varies. Yeah. The wavelength we varies. Okay. This one on the top one there. Lambda, yeah. We varies. Okay. Right. And then we have the speed of light, which is 3 times or approximately about 2.9 or 3 times 10 to the power by 8 meter per second. We have the Planck, the Planck constant. Planck constant, whereby Planck constant is 6.6 times to the power by 10 power by negative 34 joule per second. Joule second. And we have the Boltzmann constant K, which is 1.38 times to the power by 10 power by negative 23 joule per Kelvin. Right. Now this the formula or the function, okay, that explain about the variation of the temperature and wavelength. We should respect to the black body radiation capability. From this formula, yeah, you have to notice that this formula is gained from the mathematical modeling and together with the experimental work as well. Yeah. Okay, right. So from this formula, what we can predict is, okay, we can have this graph. This is the Planck law all about. Okay. This is, you can see from the graph, this is the spectral radiant flux. This is the wavelength. The wavelength from all of them, yeah, all this, yeah. Okay, if the temperature is increased at 200, you can see the distribution of the pattern of the black body distribution is like this. Okay, at 200 Kelvin. Okay, 200 Kelvin. At 300 Kelvin, become like this. See, similar shape, but we can see it increased and it shifted. I mean, you see this curve is shifted like that. It's shifted. This position. This is my maximum position. The maximum position we shifted is as the temperature is increased. As the temperature is increased at 300, then the position is here. As increased to 500 is here. It's increased to 1000 is here. At 2K is here. 4K is here. And last one is 6K is here. Now, this is a pattern. How the Planck's radiation distribution look like. Mean that at 600, you can see the flux is higher. The maximum flux is higher. Yeah? Okay? Right. Now, what Planck's low state? Black body formula work very well as the celestial body is a planet, yeah? And I say celestial body is like a planet, yeah, for example. And then where lambda is this one. So this is given by this. The energy from the black body is given by this formula. Yeah, by A divided by lambda phi exponential B over lambda T. And this formula is quite similar to this formula as well. Okay. Whereby the main function here, as I said, the temperature and the lambda. The temperature and with the wavelength. Two things. Yeah, respect to here. Right now we go with the next one. Another half an hour to go. Now, this is very nice curve that represent all. Now see, this is the region of your electromagnetic wave. On the top one, you see, we have our ultraviolet just now. This is the visible light. Ultraviolet. This is ultraviolet. Infrared. This is infrared. Infrared, ultraviolet. Infrared, this is visible light. This is the regime that we can see. Right? Okay? Right. This is, now, the regime that we can see is this one. Right? Mean that this 3000 is only suitable for infrared. Yeah. This one here. Right. Then we have 4000. Okay. And then 5000. 6000. See, visible is here. More region of visible at this 6,000. Sorry, 6,000. Okay, but quite small at 3,000. You see the curve now. You see the maximum position. The lambda max position will be what shifted like that. Okay, right. So this is the distribution of the black body radiation. Another one we have to describe this black body we have to use another two kind of law, what they call as Stephen-Boltzmann law. Stephen-Boltzmann law. Whereby Stephen-Boltzmann law, yeah, it said that E energy from the solar equivalent to sigma T power by 4. Whereby the E is the total energy emitted, the radial energy, whereby this E is the remote to radiant energy, and sigma is a constant, and T4 is the temperature. Now this Stephen-Boltzmann law is derived from this observation. Yeah, see, as the T is changed, now you can see the T is shifted. Now you see what the T4, T power 4. Another one, we have to use the Wien's law. Yeah, the Wien's law. Now this law says that the wavelength of the peak radiant or lambda max, this lambda max, this one lambda max, lambda max, decrease linearly. Okay, lambda max is decrease linearly as the temperature is increased. Yeah, the wavelength is decreased. You can see now, as the temperature is decreased, this one is what? Decrease. Yeah, this one is increase. Is inverse order. Now, what all the three law say? What can we summarize from the Planck law, from the Stephen-Boltzmann law, from this Wien's law? We can summarize as follows. Planck's law gives us the shape of the curve. From the Planck's law, we can have this curve. One of the curve here. And this curve. This curve. This curve. While Stephen-Boltzmann tells us how much more energy comes from the sun than from the earth. This is what Stephen-Boltzmann said. And what about Wien's law tell us? It tells us that the hot sun is much bluer than the cooler earth. So for further detail, you can read what is Wien's law is. Okay? You can type over here Wien's law. Then you can read more detail. You can read more detail about this. Okay? More detail. Please read. Okay? Right. This one. All this. Wien's law, yeah? You can read. Okay. This one. Relationship between the true temperature of the black body T in the degree of Kelvin and the speed spectrum. Speed spectrum with respect to this peak. Yeah. Exists or dominant by wavelength is described by this formula. Lambda equivalent to K over T. Okay. This one. Lambda over K over T. This one. K, whereby K is a C. Speed of light. Sorry, the K is a constant. I'm sorry. K is a constant. Yeah. Okay. Right. Now, I want all of you to read more detail about this law, Planck's law, Stephen-Boltzmann, and Wien's law by Google, and then you read. Okay, and then you save and then take out in the note. Yeah. Okay. Right. More detail. Right. Now we go ahead with the concept of emissivity. What is emissivity? Emissivity is the capability. This one is quite related to the black body radiation concept. Yeah. It's very related with the black body radiation. As I said just now, if you want to buy a car, you need to buy a what? Better to buy a white color or gray color. Why? Because in terms of emissivity. Emissivity is the capability of the object that according to the color to absorb the solar energy. That's one. That's it. Yeah. That is emissivity. Okay, emissivity, yeah. The capability of the object to absorb the solar energy, which is respect to the color of the object. Okay, emissivity can be defined as a follow. Radiation energy of the object divided by radiant energy of the black body with the same temperature as the object. So this emissivity range is in range of as is a ratio. Therefore, the value of this emissivity is about from 0 to 1. 0 to 1. Okay, 0 to 1. Now, if you get 1, mean that we have a perfect black body. Perfect black body. If the value of this emissivity is 1, it means you get a perfect black body. You understand, yeah? You get a perfect black body. 1. Perfect, yeah? Black body, yeah? If the value is less than 1, it's not black body anymore. It becomes maybe gray body. Gray, according to the color. According to the color. And also, maybe some selective radiator, like you got some is black, some if you get a multicolor, then you get some are black, some are gray, it can become like this. And white, it could be here, white color. If you go white color, become like that. Now, this is a concept of emissivity. Well, from here, if using that, and then we will put the superimpose with the black body curve, then finally what we have? A perfect black body can become to be a distribution like this. Wow, for this one, yeah, this is according to this law just now. This law, yeah. But if you use, you can modify this black body to become by what? Changing the color. By you changing the color, it become like this. The selective radiator then. See? That's why in solar panel as well, in fabricate the solar panel, they need also to consider on the color as well. The color of the solar panel surface. Black color, blue color, which one? Okay? In order to, so in this context, which color is efficient to absorb solar? The answer is the black color. The black color. So in order to accumulate, in order to install the thermal collector, we need a black color. Yeah? It's very suitable. Because black color is suitable for this. Now, this is some other one. Some other note. It's quite similar to the top one just now, the previous one. Okay, I can neglect that one. Okay, now we still have another time to go. Another 30 minutes to go. Then we go next with the solar distribution. As we know, on the surface of, we are on the Earth, and the Earth, we have the equator line, the solstice line. We, Malaysia and Indonesia, are somewhere around, allocated somewhere around the equator line. Equator line that we don't have any 4 seasons. Yeah, we only have a rainy season and drought season. That's it. But you go to a country on the this atmosphere area, and then this one, northern or southern part. Yeah, northern or southern part. Even if you go to Thailand, for example, this is more to monsoon tropical climate. Am I right? We need to have some knowledge in geography as well. We need some knowledge in geography. It's not only physics, but you need to have some knowledge in geography as well. Yeah. Luckily, all of us learn geography in the school. Yeah. All of you already have some background knowledge of on geography. Geography. Now you see, geography are related to physics. You see now. I have during my geography is one of my favorite subject when I am in the secondary school long time ago. Yeah. That's why as a physicist, now what I trying to say, as a physicist, you need to have some other background knowledge. They will allow you and then make it easy for you to understand more things surround us. You know, physics, what is it? Physics. Why when we say physics? Why physics? Physics a knowledge of according to the observation around us. We observe on the what we have around us. When we say about one around everything is around us, if you're living somewhere around the equator country, so you know about the weather. Yeah. Okay. Now the green color one could be the green color there. This is the tropical climate. Yeah. Equator line. And this is monsoon tropical climate. The blue color could be a Mediterranean climate. Mediterranean climate somewhere around here. Yeah, the blue color. And then we have the now, but yeah, we have what? Another season. Okay, very cold area then. Yeah, right. Four season country. That one on the path here. UK over here. Russia. Now, therefore, according to this, what you can see, as all the country which are on the equator line, of course, we receive more sunlight every year, more solar energy every year, compared to other country like UK, like they also have, but we need to notice. For example, in Norway, in Greenland, the people in Norway, in Scandinavia country, they only get daytime very short time of period. I still remember when I studied in UK long time ago. Daytime during winter time is very short. Daytime is only around, frankly speaking, daytime is about 8:30 to 9 o'clock, 8:30 something like that, and 4 o'clock is already Maghrib. A very short time. I remember when my first year at Bristol University long time ago, in UK, during Ramadan, we fast about very short time period, and we break our fast about iftar about 4 something. It's already Maghrib. Very short, but in very cold weather. It's not easy. Fasting, when you fast in the cold weather, it's not easy, because you feel very cold. Very cold indeed. Now, okay, talking about distribution, even though this is the tropical country, but you see, there is a special spot that receive a maximum energy. What spot is it? This all the spot. The black spot. Yeah, this black spot. This is somewhere around where? The desert in Australia. What desert is it? What desert in Australia? You find out. This is what? Gobi Desert. Gobi Desert. This is Arabian Desert. Yeah, this is Sahara Desert. Okay. This is Atacama Desert, I think. Mojave. Yeah, desert. This could be Atacama Desert, I think. Yeah. Atacama Desert in South Africa. Now you see all this point location are black spot area. This area receive the highest amount of solar energy every year. Okay, at this spot. So if you look at on the power, the color here, according to this color, okay, all the spot color, the black one is mainly red, quite nearly to red color one. Yeah, we receive about approximately 300 watt per meter of energy. This spot, that spot, yeah, and the spot. While in Malaysia or Indonesia, we are somewhere around approximately around 200 something, 200 to 250. This one. That you have to notice that even though we receive yellow color, but in reality, our geographical of the features of Malaysia and Indonesia covered by what? Rainforest. We are covered with rainforest, a big tree. Yeah, only small spot of area can receive. In Malaysia, in Indonesia, something like that. Right now, all this spot, all the sea area, 1, 2, 3, 4, 5, 6. All the sea area is mainly located somewhere around the desert. All the sea area are called the sea area are all in the sun belt. We call sun belt region. All this. 1, 2, 3, 4, 5, 6. All the 6 points we call as sun belt region of Earth, which is mainly empty desert. Yeah, nothing can survive here. You see, if nothing can survive in Sahara Desert, how can? You see, if you go to the Mars just now, maybe to the Venus, looking to the planet, how can we survive? Even on the Earth now, we have the Sahara. We cannot survive on Sahara Desert. How can you survive to another planet, like a Mercury planet? Now you can imagine. It's very hard. That's why, what you can see. Thanks to our God, thanks to Allah, because Allah have created the earth. The earth is a special place for all humankind. Okay? It's perfect. The earth is perfect. The perfect place for us, for all the creatures to live, compared to other planet. Then maybe some of you could asking me why. So what is the function of all the planet? What is the function of the planet then? Cannot your people, the human being cannot survive in the planet. So what? Why? Only God can. Yeah. So we go back to God then. All right. This is all about equilibrium. In physics, we have the concept of equilibrium. Keseimbangan, equilibrium. Okay. Right now, this one you can read. This one, what I said just now, tropical Cancer. Then we have the Capricorn. Yeah. Okay. Next one, we go to atmosphere. Atmosphere. What is atmosphere? Atmosphere is, as I said, is mainly contained with the layer by layer. And we talk about this. The Earth atmosphere is very thin layer, as I said, as I show you just now. Very thin layer. Very thin layer. Yeah, as I said, very thin. See the layer, very thin. What I said is this layer. That layer, very thin. You see now, this one? This one, yeah, very thin, yeah? Very thin layer. Layer mean this one. See now, this is outer space. This is the surface of Earth. Very thin, very thin. But actually, it's a several 100 kilometers if you want to travel to here. Yeah. Okay. Even though it's very thin, you see, you cannot imagine. Yeah. We mean that we are very small. We human beings are very, very small. Then even you compare the size of the Earth with the other planet, then you can see. But we talk about the distance from the surface of the ground of the Earth. Even you want to travel to this location, it's actually very high. It's up to 10 kilometer, 20 kilometer upward. It's not easy. And whereby we know that the International Space Station is somewhere around here. Yeah, it's orbit around here. Okay. Yeah, that is the Earth is wrapped by a very thin layer, which is mainly this atmosphere contained with the nitrogen, comprised about 78% of nitrogen, oxygen 21%, and other makeup of other some other gases. Now, and we talk about this based on the temperature, based on the temperature. Therefore, because of the different temperature, the atmosphere can be divided into four layers, which is we call as troposphere, stratosphere, mesosphere, and thermosphere. You got four. All this atmosphere divided according to the temperature. Okay. Now, if you look at from here, this is the atmosphere. I said very thin. This is a picture from NASA. You can see like this. Yeah. The horizon. On the horizon, you can see. This is how the atmosphere look like. It's contained mainly with this one, nitrogen, 21% of oxygen, and we can survive because of oxygen. 21%, you imagine? Yeah? Atmosphere contain only 21% of oxygen only. Okay, yeah? Now we think about we can live on the earth, we think that 100% are covered by oxygen. No. Actually, it's only 21% from the atmosphere is covered by oxygen. The rest is nitrogen. So what happens if there is reduction of oxygen? How can oxygen is maintained? Because of photosynthesis. As I said, you see now, leaf produce photosynthesis. Then the leaf of the tree will produce oxygen. Now you imagine, yeah, this is what I call as equilibrium. If there is no sun, how can the leaf make a photosynthesis? If there is no photosynthesis, no oxygen then. No supply of oxygen. Now we talk about the thin layer of this. We talk about the thin layer of the wrap around the planet of the Earth. We talk about this. This is the thin layer. The definition of the thin layer, as we said now, this one. And also because of the cloud, atmosphere is divided according to the temperature. We go rising up, you go upward here, the temperature very cold. It's very cold here. Very cold temperature. Yeah. Very cold or very hot. Very cold or very hot. This here is quite hot. Over here is, this one you go to the Everest mountain, you go to Kinabalu mountain. You feel very cold. Yeah, actually very cold. But up here, we have the ozone maximum. But this one is quite hot area. What you call this one? We have the thermo. Thermo indicate the temperature over here is quite hot because of the sunlight. Yeah, it's very close to the. Because the word thermosphere mean that that's why you can see when the space shuttle go to outer space. I hope there is a photo, yeah. Image. No image. You see if there's a capsule. I think capsule, space capsule, I think. This capsule, yeah, this capsule. You see now? This one. This capsule, one after the if one, the astronaut want to go back to the Earth, we need to use this capsule. So normally it will fall by gravity. During it fall out from the space to the gravity, you see, one after it reach to the this is thermosphere. Thermosphere. Then it's very hot. Let's make the surface of this capsule tend to be like this because of this thermosphere. Okay, right. This is and the area at 100 from 800 to 100 kilometer. Now you imagine you drive from 800 kilometer. Can you imagine? You drive from where? From here to 800 kilometer, approximately from Parit Raja to Johor Bahru, or maybe to Singapore. You can imagine, yeah, the thickness of this. Yeah. But the attitude, attitude means that it vertical height, vertical, yeah. You go to the vertical about after 800 kilometer, after 80 kilometer, 80 kilometer, then you see this one. So mean that the flight, the commercial flight normally travel at this one. That's why we got the tropo, we got strato, we got meso, we got thermo. Mean that all the commercial aircraft normally can travel at the troposphere only. And this is the maximum region. Mean that 30 kilometer above us are ozone. Mean that the flight only travel approximately about 10 kilometer from the surface of our Earth. The plane that you can see very tiny, sometimes you see the plane, yeah, the aircraft travel around us. You can see. You go to clear, yeah. You can see very clear. One after the flight, the aircraft reach to the airport, and you can see very clear. Become very tiny to become very big and big and big. Then see, the aircraft only can travel approximately about 20 kilometer. It depends. For the commercial, can travel about 10 kilometer on the top of the ground. On the top of the ground. Okay? Right? The height, the vertical height. While the maybe aircraft fighter, 20. Okay. Mean that all the aircraft except the space shuttle. That's why when the astronaut want to go to the moon, they need a very high power space shuttle, and they need a power, yeah, this is indirectly at the vertical upward. They need the up thrust power, yeah, upward to go here. You need what does it mean? The space shuttle, all the astronauts, when they go to the space station, they have to travel about 100 more than 100 kilometer, yeah, to reach to the outer space. Okay, right now talking about this, what we have this is the layer, the ozone layer. I mean the ozone layer is about 30 kilometer only. 30 kilometer only. Yeah, after 30 kilometer, we get this one. After you climb about 40 kilometer, then you get the stratosphere. After you climb at the 60 kilometers, we found the mesosphere and then thermosphere. The word thermo, tropo, strato, meso, thermo. Thermo means they're very hot. Turbo, strato, and this one is according to the type of the cloud. This is a characteristic of the cloud. At this position, meso cloud, stratus cloud, turbo cloud. Right, nice. Talking about this. Okay, this one I will continue. I stop a bit on this. Okay. So I stop. Now it's already 4 o'clock. Okay, we finish. Next week, I will explain a bit on this one. And the atmospheric. This one, up to here. And then why we need to know this? Because these concepts are very important because of this. All the cloud will be one of the factors that reflect the sunlight. That's why we need to know on this. Okay, but it's quite interesting when we discuss about this. Okay, right. So next week, please remind me. I hope some of you can remind me. We stop at this topic: solar interaction with atmospheric gases. Anybody can remind me on this? So mean that next week when I give you lecture, we be straight away start with this. So by that, we end up our lecture. Yeah. So allow me to stop recording. Okay. See you next week. So next week we continue on this topic a bit, and then afterward we will go with the chapter 5. So next week will be half 1 hour. Half the first 1 hour we discuss on this concept of. Next week we cover on this 1 hour. The first 1 hour we cover on this, and then afterward the next 1 hour we will proceed on the next topic on solar panel. I think solar panel. Yeah. So I mean that this topic cover 2 weeks. We are somewhere around week 6, but we are quite advanced now. We have already here week 6 and week 7. So I mean that week 6 and 7 we'll cover on this. Yeah. And next week as well, we start with this as well. 7 and could be 8. All right. Right. So by that, before I end up, I need to remind everybody. Yeah, I need to remind everybody that your test could be covered from chapter 5. Your test 2, yeah, not chapter 1. Not test 1 is done already. Test 2 will cover from chapter 5, chapter 4, chapter 5 to chapter 6. I repeat again. For your test 2, we cover from chapter 4, chapter 5, and chapter 6. This is your test 2. Okay, and then we are nearly at the end. And then afterward, for your assignment. So your assignment 2 will be given somewhere around maybe next week. I will give you assignment 2. Assignment 2, inshallah, will give you all of you. Yeah, please. All right, so by that, I stop the recording now. So I will upload this lecture in our YouTube channel. Thank you.